Least, and thank you all for sticking around. I know we're over our time, is RiCo, Risk of COVID, and presenters are Tarun Mamidi, T. Tran Nguyen, and Ryan L. Melvin, and is Liz Worthy.
Thanks, and just to confirm, you can all see my slides and not my notes, correct?
Correct, and we can
all right.
see the video.
Perfect. So we were RiCo, Risk of COVID. And we've already given an introduction. My teammates will be in the chat trying to actively answer questions, so be sure to throw those out if you have any. Our project jumped off from a recent systematic sort of meta-analysis of the symptoms that are predictive of COVID infection. We wanted to figure out what medical conditions could be identified as risk factors for COVID and use them to generate a risk score. Now, by medical conditions, we ended up having to reduce that definition down to ICD-10 codes. And by risk score, we wanted something that could stratify patients into high-risk, low-risk groups with no black boxes and could even be calculated on a piece of paper if needed. Our main aim was to develop a pipeline for as more data comes in and a working web app. So as you get more and better data, and I'll tell you what I mean by that later, you can just shove it through our pipeline and deploy it on the web immediately. To develop our model, we looked at over 6 databases and 20 data sets, examining what we could possibly use. In fact, Tarun on our team spent several sleepless nights in doing work ahead to figure out what data would be usable for our goals. We eventually settled on the UAB LDS N3C data. So we are grateful for having that fairly clean and exhaustive data set from UAB medical records. As you know, EHR is quite messy, so data was a challenge here. We only looked at the cohort 1 and cohort 3 groups. If you've examined that data set, there was a middle group, but we looked at the confirmed positive and confirmed negative groups only. And out of that, we still had a lot of data. This table is mainly to impress you that we filtered the data down. One surprising thing, though, is we actually, contradictory to the literature, found that the positive group had more women than men. So this is the first instance in my talk of UAB data not completely agreeing with the literature. We'll see that more and more. So once we had that data selected and reduced down to cohort 1 and 3, we still had to do some filtering. So this was a challenge, and we spent a long time debating it. How do you define what is and is not a COVID symptom, especially when you have an entire patient's EHR? Do I care if a patient had a headache a year ago? Maybe not. Do I care if they had asthma a year ago? Maybe so. So there was quite a bit of filtering, and we debated how to do that. We eventually ended up with these features that I've shown on screen: demographics about the patient, their ICD-10 codes, substance use, which includes tobacco, alcohol, and other substances. And we also looked at the PCR and antibody tests to really understand what positive and negative meant. We had to process this data by dealing with some missings. Even though it was fairly clean from the N3C setup, there was still some missing. And then we needed to merge and map. So we were mapping from basically text notes over to ICD-10 codes. So they were fairly easy to map, but we did have to deal with this data set that was essentially just a whole bunch of rows per patient and text notes that we had to figure out what ICD-10 code they matched up with using OMOP. And then we needed to get those into categorical form for use in our models. We considered over 10 different models. These were all of the type called credit scorecard. So this is essentially logistic regression with friendly numbers added at the end. To do that, we had to bend some of the information. We, of course, split into a train test pair, so 80-20, randomly selected. And then because we did not think we had time to really do an exhaustive feature search using some of the more advanced techniques that would need to run over several days, instead what we did was we used what's called information values. It's a somewhat old school way of doing initial feature paring down. You figure out what is most predictive and then maybe select like the top 100 things to really dig into. Credit scorecard models rely heavily on what's called a weight of evidence transformation. This is essentially a log of number of good outcomes over number of bad outcomes. And that transformation ensures that you have a strict linear relationship of your variables to your log odds of your outcome. So we sort of bake in all of the assumptions of a logistic regression by performing what's called weight of evidence transformation on all of our features. Then we do logistic regression, and we get some feature scores. So again, we considered 10 models with various ways of filtering, various ways of building the models, and pared those down based on agreement to literature, information about how accurate it was, and honestly, some intuitiveness of the results. So we introduced bias, we understand that. Eventually, we came to, we're only going to think about what's happened to a patient in the last 2 weeks. So what symptoms have you presented in the last 2 weeks? And we will use those to examine your risk of being COVID infected. I should have mentioned this at the start of the slide, but what's been playing over there in the left-hand corner is a demo of our working web app. You answer some questions. This web app assigns you a score that I think is quite friendly. We're all used to looking at our credit scores, and this is similarly interpretable, except here a higher number is bad. And then we chose a cutoff that essentially reflects, given the fact that you're asking about your symptoms anyway, if you're at least 20% likely to be infected by COVID, under our analysis, we recommend that you take a test. So if you saw that cutoff switching to, please take a test, that was the 20% cutoff. As far as our findings, I'm sure we all remember our ICD-10 codes. So this is our scorecard. You know, as a patient, you figure out what ICD-10 code you have, and then you pick the number that goes with it. I'm just kidding. We turn these into friendly questions. So essentially, someone can just go down and answer these questions, tally up their points along with what's the base score. So this is, you can think of this as the intercept, and you get your score. You know how high a risk you are of being at COVID. Along these findings, there are places where we agreed with the literature, which I've highlighted in yellow. So unsurprising, cough is predictive, fever is predictive, and again, a higher number means more at risk. There are, however, places where our findings disagreed with the literature, and I've highlighted those in red. So heart disease and lung disease turned out to be, in our analysis, protective against COVID. We think that that is more about medication because we are looking at ICD-10 codes. We think that this means that you are under treatment for those things and that treatment is somehow protective. However, we did not have the time to really dig into that. So that is a hypothesis for future work. We also disagreed on age group, though I think this is really a failing. We should have just put 55 into that 40 to 54 group as well. And that probably would have made more sense. Another place we agree with very recent literature, JAMA this morning, I believe, published that Hispanic and Latino is grouping is predictive of COVID. And so that should also be highlighted yellow as of yesterday. As far as the rigor of our model, I will be honest, not great, not terrible. And if you're a fan of HBO, you might find that funny. So as you can see from our ROCs, we're doing certainly better than chance, but again, the real goal of our project wasn't to have a super perfect model. We wanted to prove that we could develop this pipeline for rapid deployment as more data comes in. So that's what the two figures on the right are telling us. The figure on the left, it seems intimidating, but what it really tells you is in our score bins, and 213 is that place where we said, hey, if you've scored 213 or higher, please take a COVID test. These are our actual populations from our data in these bins. And then these lines at the top are telling you from the train and test sets where patients actually fell. So it's a little maybe counterintuitive to read, but essentially as you move to the right, you are more and more likely to be infected with COVID. This should actually say good probability, my bad. So you are more and more likely to be infected with COVID as you move to the right. We're actually seeing that in the population. So our model is doing what in a big picture we say it should do. Higher score, more likely to be infected. And if you're not familiar with scorecard models, this PSI, you can think of it sort of as like a p-value for a scorecard model. Anything less than 0.1 means that what I'm saying about the population tends to hold on an individual level. All right. Some other things we learned besides just building our model. So we found that anxiety is a protective term. Again, we're not sure what that means in terms of is it just medication or a doctor monitoring you, but that was an interesting finding. We use ICD-10 codes, but we figured out that they can be a little too limiting and granular. If you use the full code, that means that someone may actually be entering different codes for essentially the same thing. So we settled on shortening ICD-10s to just the part before the period. Also, we ended up just going with a binary case because I think it's a sample size issue, but number of visits for a given symptom, so like 1, 3, or 5 visits for a headache, had a V shape in terms of being predictive of COVID, but we really think that's more of a sample size issue. This little graph here on the right is a preview for the next slide of how picture on the right is a preview for how we think we've contributed to the understanding. So UAB has actually launched a COVID symptom tracker. I took the survey yesterday, and they are just tracking. What we think we could contribute, honestly, to that very tracker is a way for, at the end of you taking the survey, a concrete recommendation and a score that's easily interpretable. Along with our model can tell you why we think you're at high risk. So we can give you a very concrete answer to that because it is essentially all a linear relationship because of the technique we've chosen. We wanted to say thank you to everyone who's built up the framework for us doing this. So we use several tools that are fairly recent, Streamlit for getting our web app up and running. Our scorecard, which is meant for the financial industry, but we sort of co-opted it over here for the medical work. It's meant for building credit scorecards. And then, of course, all the UBright folks. So we use the UAB N3C data set. We are so grateful for having that relatively clean and prepped. Thank you so much. The GitLab that you've set up for us. And then, of course, July and Matt were excellent resources for helping us getting things going. And at some point, we looked at pretty much all of the UBright COVID-19 data sets to some extent. Like I said, Tarun basically didn't sleep for 3 days doing that work ahead.
For that, actually, we have to go to questions now, and I hope you guys have gotten some sleep since then. Questions. Are you conflating metrics that predict risk of being infected versus metrics that predict outcome?
We tried hard to avoid that by looking at how we filtered that time window. That's one of the things we wanted to work on in the future, though, is really narrowing down when you will be when we will consider a diagnosis to be predictive of infection. We did look at what codes reflect or have been used for like emergency COVID labeling, and none of those are actually in our model. So we don't have like a COVID diagnosis in our model by accident.
Yeah, would you recommend that providers and health professionals use this in their care?
Yeah, so we think this isn't just for the patient. We think that while it is intuitive at a patient level, you could also just have nurses and doctors asking these questions, or, you know, as you come in, the person who is admitting you just asking these questions really quickly and getting your COVID score.
How do you define risk? Is this risk of getting infected or mortality or critical care intubation or slow recovery?
In this case, it was whether you were in the confirmed positive or confirmed negative group. So we are trying to ultimately predict which bin you're going to fall into.
Okay, and I think the final question is going to be, do you think clinical data is too noisy to get an accurate risk predictor?
We certainly felt that way when we looked at the full ICD-10 codes. In fact, when we did that, the only signal that showed up was cough. Not really anything exciting there. So the answer is mostly yes, and we need to explore other potential features.
All right, thanks everybody. And thank you everybody for participating, and everybody who helped and planned and mentored and also is judging this. So we will we'll have to convene and tabulate our responses, and we will have our closing ceremony and awards presentations at this same time. Won't be quite as long next Friday.